Welcome to Unit 1, Section 1.2, Data, Conditions, Loops, Graphics, and Organization. First thing we're going to look at. Welcome to Section 1.2 of Unit 1. We're going to cover data, conditions, loops, graphics, and organization. This is just a very brief intro to these topics to get you used to some of the terminology and the overlying concepts. First, the term data. The definition of that is which is information stored inside the computer to be used for making a decision, a calculation, or an analysis. And your computers are essentially just a large collection of data, and we'll be using all that data that we gather from our game programs, and the goal is to take all that data and then we'll turn that into some sort of information that we can use for some sort of decision-making process. And the data can come in all different types of formats, such as numerical data that's being put in by the computer, or it could be data entered in from the user actually entering numerical information, or the user entering words, or pressing keys, or talking into a microphone, or pressing buttons on a controller. So there's lots of different types of data that comes into the computer. Now what's important is whenever the data does come into a computer, we have a term here called variables. And variables are going to be the storage containers for the data. So all the information that gets stored inside of a computer is going to be stored inside a variable. If you think about them, they're just storage locations inside the computer, and these storage locations are very versatile and they change. They're very dynamic. They can be stored in different locations all over your computer or your hard drive, just depending on how your computer is organized. Some things that these data can do is they can help keep track of the user scores, they can turn sound effects on and off, they can identify the level the user's on, how many lives the player has left, and they can also store some percentages for determining random events. When we create variables, one of the first things we need to do is give them a name. And when we give them a name, it needs to be related to what we are storing or what the variable is storing. This is going to help you stay organized, and it also helps you to remember what that variable was used for. There's going to be situations where you may not look at your program for a day, maybe a week, maybe a month, you never know, and you're going to forget what these variables were used for. And if you use some sort of weird name that doesn't really have anything to do with what you're doing, there's a good chance you'll probably forget what it is. Or if you use something that's very generic. For example, we want to create a variable to keep track of the player's score. A good name for the variable would be score. If you use names like variable 1 or variable 2, that's not going to be very precise or very good for long-term usage of your program, or it wouldn't allow other people that looked at your program to be able to go and see what you're doing. Next, we have variable types. There's a lot of different variable types in the world of computer science and computer programming. We're going to mainly deal with 4 variable types. The first type is called an integer. You've probably seen this in your math class. If you haven't, that's okay. And integers, they can be any positive or negative number. And you'll notice that I have some examples right here. And over here on the far right-hand column, you'll see that we have an example of what an integer would look like if it was stored inside of a variable called score. Next, we have a floating variable, and a floating variable is a number with a decimal, and it can be positive or negative. There's some examples below right here, such as 1.2, negative 3.1, 89.7, 0.232, negative 1.00054. Okay, so those are examples of floating numbers. Don't worry so much about where in the world did we get this name float from. But what you need to think about is, okay, any number with a decimal place is going to be called a float value, and it stores decimal points. Computers don't think like humans, so we have to be very precise in how we give the information to the computer so it knows how to calculate that. Believe it or not, computers are not very good at math unless the human that's programming them makes them very good at math. So you will be in control of the machine. Now the good news about Scratch is we don't really have to worry too much about what we call declaring variables, where that means we have to tell the computer in advance what the variable will be storing. The cool thing about Scratch is we can change that whenever we want to. So it's going to give you a lot of flexibility when you start learning how to program. And again, here in the right hand column, I have another variable called distance, and I have information in there that's negative 23.2. Just to give you an example. Next, we have string variables. These are going to be like characters, letters, that can also be numbers stored as string. The main thing about string values are that they cannot be used with calculations. So anything that's entered as a string cannot be used for a calculation. In this case, we have these the variable's name, which is just taking in people's names, which are just letters. So you wouldn't really use those for any sort of calculation. And finally, we have Boolean, which is probably the best name in computer science. And Booleans store true or false values. And there's some different ways in Scratch where we can declare a Boolean variable. We can have it set up where we put in a 0 for false or a 1 for true, or you can also just type in the word false or true. However, in Scratch, since Scratch doesn't have us declare variables, like I was telling you before, where we have to tell the computer what it's using, like in Java and C#, where we would tell the computer, say, hey, I'm using a Boolean, this variable can only store Booleans. In that case, it's automatically going to expect a true or false. So what I like to do for my Booleans, I like to use a 0 for false and 1 for true inside of Scratch. And the reason being is it helps alleviate any sort of misspelling with the value inside the variable. So we don't have to worry about spelling. We just know it's going to be a 1 or a 0. And that way there's no confusion with the users, especially if they're kind of new to typing, they accidentally hit the wrong key or something. So there's no worry of any misspelled words. Next, we're going to talk about data lists. Data lists are essentially arrays. We're not going to use the term array too many times because in Scratch they don't use the word array whenever you create a data list, but just keep that in the back of your mind. If you start seeing more advanced languages like Java and C#, that they'll be using the term arrays for your data list. And a data list is a collection of information that's related to each other and it's organized. These can also be related to terms, the arrays, which we just talked about. And these data lists can be used for storing anything. If you have a cell phone, you have multiple data lists already stored on your phone. Your brain, even though it's not technically a machine, if you want to get in all that kind of conversation, but long story short, you have lists built into your brain. Those are data lists. Okay, so if you think of the list of all of the names of people you know, or all the states you've ever visited, or all the countries you've visited, or your favorite foods, those are all lists, and those are a list of data. Okay, and data lists in computers, they can be different types of information that can be stored. They can be string values, they can be floating values, they can be integer values, they can be any of those type of things. And when we get more advanced topics of computer programming, these data lists can also store objects, and each item in the data list technically is an object. Okay, and that's pretty advanced because we haven't really even started programming yet. But just keep that in the back of your mind that each item in the data list is going to be called an object. And if you think about whenever you play a video game, let's say Super Mario Brothers or Pac-Man, those are kind of older games. You probably had a good chance of seeing those. Say Pac-Man, the little yellow circle eating the pellets. Pac-Man was an object, okay? And the computer would have a data list of all the different Pac-Men that you could have, okay? Well, assuming there's different type of Pac-Man. All right, so next bullet point, every object in your data list has a certain location, and that's called its index number. If you look over here on my list of contacts, we have index numbers on the left-hand side for representing each of the different entries into my data list. So my dog Rowdy, he's at index position number 3. And these items can be removed or they can have additional names added to them. Okay, so this is a very versatile and a very dynamic data list. Conditions are a feature in programming which allows the computer to perform a different task based upon certain events being true or false. Okay, so all variable types can be used as a condition statement to check to see if they're true or false. For example, down here in this little piece of code, we say if X is equal to Dave and if Y is equal to Anna, then we ask, does X equal Y? And the answer is no, this is false. Okay, so this is a condition. We're just seeing if these two are equal to each other, which they're not, so that is false. Okay, and we'll be doing this all the time when we program. We're checking to see if these different variables or different values we put in the computer, if they're true or false, and this helps us make decisions. For example, we're going to be using quite a bit of these if and else statements right here. And we can use these to compare different value types. For example, if our score is greater than our opponent's score, then let's celebrate. And it's kind of fuzzy. Hopefully you can read that. I'm not sure what I did when I copy and paste that clip art there. Not clip art, but when I snagged the screen. So we're saying if our score is greater than our opponent's score, if that's true, then we'll celebrate. Then over here, if that variable says if it's rained today, if that's true, then we'll use my umbrella, and if not, then we're going to come down here and do this lower condition right here. Okay, so those are conditions. If something's true, we do one thing. If it's false, then we do another. Another important concept in computer programming is looping. Looping is repeating a piece of code either forever or until a certain condition is reached. A loop that runs forever is called an infinite loop. You'll see quite a bit of these. And some computer programs need to keep running, such as ones that control air traffic control systems, medical equipment, sewage treatment plants, radar systems for our military defense systems. Anything that you can imagine that would need a computer where it's constantly running would be on some sort of loop system where it's constantly going through a series of reiterations of the code, and it's going to keep going till it meets a condition, or well, until it loses electricity, which hopefully not. The picture on the left is an example of a loop that will run till a condition is met, and the picture on the right is a loop that goes on forever. So on the left-hand picture, right down here, okay, this is going to repeat until the variable called music equals stop. Okay, so it's just going to keep repeating that piece of code inside of it, which is called keep dance. And this is a custom-made Scratch block, just for the record. Now that same holds true for the previous slide as well. So we're just going to keep dancing until the music is equal to stop. Okay, don't worry about what values are in there. Just think of the overall concept. As long as the music's playing, we're going to keep dancing. Okay, over here on this side, we have a forever loop. And this loop is just going to keep going on forever. We're going to breathe in oxygen and exhale carbon dioxide. All right, so that's something that you would want to do forever. And we're going to keep repeating these pieces of code over and over and over again. Here is a little bit more information about looping. We have the repeat block. It'll keep repeating the code inside of it based upon the number of times it is told to repeat. And I'm looking at this block of code right here. Okay, so what we're telling the computer is we're going to repeat this loop 10 times, and inside of it we have a block called move 10 steps, and we're going to perform this 10 times. So if we repeat this 10 times and move 10 steps each time we go through the loop, that means the sprite would move a total of 100 steps. Okay, and just for the record, the computer does not measure movement in steps. That's a Scratch term. We'll actually measure movements in pixels. Okay, we'll worry about all that stuff later. Right? In pixels, that's kind of loosely defined as well. All right, the only type of block that cannot fit inside of a looping block is a hat block. So those were the green flags and the whenever I received broadcasts, or whenever you click on this sprite type hat blocks, which were mainly located in the events section. Looping blocks can be placed inside of looping blocks. You can see that over here in this piece of code where we have this repeat block with 3 repeats inside of it. And we could have also put in the forever or repeat until blocks. Those would also work inside of another looping block. So there's a lot of different opportunities for different combinations with your looping blocks. Next, we have raster graphics. Raster graphics are the images that are made of tiny squares that are put together like a puzzle. You'll see these quite a bit when we work inside of Scratch because raster graphics are very convenient. The tiny squares are known as pixels, and these images are rich in detail. They have a lot of ability to store multiple graphics inside of a raster graphic. Some common photographs are usually raster images. So raster images require more memory due to their high resolution and complex colors. And raster graphics can be edited in Scratch, Photoshop, GIMP, or Paint.net. Those are actually 3 of the 4 are all free. Photoshop is a program you'd have to pay for, which is made by Adobe. I use Photoshop, and it's very, very convenient. However, I like to use Paint.net if I just have something very simple to use. And if you look down here at the picture of the Scratch cat, We've zoomed in on its mouth area so that way you can see a little bit of the pixelation taking place with this image. Opposite of raster graphics are vector graphics. Vector graphics use math formulas to draw lines and curves by connecting the pixel dots. This allows the user to make some images that are larger and smaller without a loss in the clarity of the image, and they are very scalable. Vector graphics can be layered. You can place one image on top of another to make a new image, and vector graphics, however, cannot handle special effects like blurring. So vector graphics, you've seen these quite a bit. You probably use them if you ever have used PowerPoint or some of the easy object images that you would find inside Microsoft Office programs or even some Adobe programs. Vector graphics are everywhere, especially if we're looking at some sort of brand logo for a company. They enjoy using vector graphics because they can make them very small for a business card or make them very large for a billboard and still have the same image with the same level of clarity. Down below, the vector cat was, or the scratch cat was drawn with vectors here, and what I did was I went into the vector editing mode of the paint tool, and I just manipulated the vector graphics to make those smooth curved lines. Okay, finally, organization and saving files properly. This is very, very, very important, especially if you plan on working extensively in programming. So organization is a fundamental skill in programming. It's a great skill when working in teams, and you want to be able to easily duplicate your efforts, and it helps find problems with your program and avoid making errors. A common problem with students is they can't find their files once they save them. They are commonly misplaced, or they don't save them in the same location, or if you're using network drives, you're not saving them in the same location that you had previously done, and it could be on some sort of weird drive letter that you didn't know was selected. Okay, so there's a lot of different areas where you can go wrong by not having a good solid organization skill. And you want to back up your files too. That's part of being organized, is having a central location where you can back everything up, and that way you can easily find your files. And if you need to, you can take those files and duplicate them and make adjustments to them. If you see something wrong, you can go back to the original file and not lose any of your settings. Saving files, this is important. Just know where they're located, make sure they're named properly, make sure you give them very good descriptive names. I always try to save in the same location with similar files. Now, that's not always going to be the case. Sometimes you have to put different files in different files in the same folder just because they're associated with each other. There's nothing wrong with that, but just try to make a rule of thumb. If you have 100 pictures, try to put all the pictures in one folder, if that makes sense. I always make a folder for any kind of project I work on, and then I put all the files located in there. And making a lot of different folders doesn't really take up too much memory on your computer. Try not to name files something generic such as document 1 or program 1 or something very generic where you can't remember what it is if you were just to see the name. It's better to be very descriptive in your file names, but don't get too large in your file names. And then finally, last bullet point, try avoid using any of these symbols in your file and folder names, just because it's just not a good habit to use these type of symbols. Different operating systems reject different types of ones. Me, just as a rule of thumb, I don't use them at all. All right, so that wraps it up for Unit 1, Section 1.2, and we will see you in the next video.